You want to see something cool? This is where Ava was created. Here, we have her mind. Fluid, imperfect, patterned, chaotic.
Okay, first of all, how cool was that intro? And did you notice that Oscar Isaac's character wasn't really looking like him? Or is it maybe that we already look very similar in that movie? Well, if you want to know how I did that, so how I swap faces, both in images and in videos, just let me know in the comments and I can do a video about that. I think it's really cool. But enough with face swapping for this video. Let's get started with this lesson. So welcome to lesson 2 of this course, Ava, the WhatsApp agent. In today's video, we're going to cover two things. At first, we're going to understand what are these frameworks for agentic systems or these agentic frameworks. And I'm going to explain you here why we chose to build Ava using LangGraph. And then when that's clear, we're going to dissect Ava's brain. And we are going to dissect it by doing three things. By looking at this diagram that Miguel has prepared. By doing a code overview, I'm going to show you all the important parts that build Ava's brain in code. So we're going to be looking at that as well. And finally, at the end of this video, I'm going to show you how you can set up LangGraph Studio so that you can run and debug your agent graph, which actually looks like this. So in lesson 1, we already defined what an AI agent is. And actually, we concluded that we shouldn't really be talking about what is a true AI agent. We should be thinking about agentic system. And now for building this kind of agentic systems, you have different options or different frameworks. And I think the first distinction that we have to make is between low code or no code tools like N8N or flowise and code frameworks like LangGraph or the new smolagents from Hugging Face. And I think the key difference between these two groups boils down to one word, which is control. Because when you have access to the code, to everything that your agent or your agentic system is doing, you can potentially build anything that you want. Well, that is if you can code it, of course. But don't get me wrong, I think these low-code applications are becoming very, very powerful. I've personally seen, not built, but seen a lot of amazing applications built, especially on N8N, which is this kind of graph-based or node-based architecture that you can just drag and drop and just connect different things. But as I said, you are limited by the integration. So you have plenty, but yeah, you depend on them implementing an integration for you. Though I believe as well that you can inject code, so you really can do a lot of things, but again, it's just not the same as having complete control over the code. Then you also have flowise and rivet, which I think allows for a lot of code injection. So this, I think that they come as this low code more than no code. And then you have make, which I think doesn't get to the level of N8N in terms of how complex the workflows that you can build or the automations that you can build are. I don't think you can create cycles, for example. So I think make is more like an automation platform more than kind of like an agentic platform. And then on the other side, we have the code frameworks. And here among these two, we have the ones that like LangGraph or crewai and Pydantic, for example, that allows for a lot of control as well for you to really control every single part of the application. Or then you also have other frameworks that have more as abstraction like LangChain or Llama Index. I personally haven't used them all, and I think you shouldn't use them all. I think you should just choose one that you feel that adapts better to your workflow and the way that you work, and just commit to it and work on it. And I encourage you that if you are already a coder or if you are not afraid of learning how to code, you should go for a coding framework. Okay, now among all these frameworks, why we chose LangGraph? And again, I think it comes back to the same word, to control, right? And what I mean by control is that LangGraph allows you to really go low level, and it removes all these abstractions that, for example, LangChain has. But as I have here, I think Also, the way that is architected as a graph, I think makes a lot of sense. And even though we go low level, I think it is still intuitive to understand what is happening in the system. Another good point for me was that, of course, it integrates nicely with LangChain because they come from the same company. And I am already a fan of LangChain. And what I really like about LangChain is just that is platform agnostic, right? That I can easily just use this inference provider, Grok, like we use here, but just change it and now use Anthropic or OpenAI or Azure, so the one that I really prefer. And finally, as a robust, really framework that it is, it allows you to have streaming, parallelization of different workflows, ready-made integrations just to make it easier for you, and also multi-agents. Now, let's put the focus back on Ava's or on Ava's brain. And let's pay attention to what I have here, which is the title of this lesson. Ava's brain is just a graph, or as Miguel likes to put it, Ava's brain is just a LangGraph. But he also added an asterisk here, which is down here, a stateful graph. And I'm going to explain you just in a couple of seconds what is this. But let us first look at this beautiful diagram that Miguel has prepared. Oh, and by the way, if you want to get the content from this lesson in written form, you also have a link to Miguel's newsletter down below in the description box. And now coming back to the diagram. So what we have here are different nodes and edges. So that is a graph, right? And let's review now all these nodes, or the most important ones. So then later on, when we go to the code, we understand it even better. So starting from the top, we have the memory extraction. So this node, what it does is to understand from the message of the user if there is a key piece of information that should be remembered, so that should be put into the long-term memory. Then we have the router node. So the router was one of these agentic patterns. And what it does is to route the flow of the application. So what is the next node that should be executed? So that's what we have here as select workflows, right? So our router node, what it does is just that Ava would decide autonomously how she will answer to us. Will she answer with a voice node? Will she answer with a text? Or will she answer with an image node? So that will depend on the kind of, or the flow of the conversation, right? So it will depend on her. And we also have another things. For example, we have a node to inject context and to inject memory. So that is, for example, Ava's activities, because Ava has a daily schedule. And also we inject those memories that could be key to form an answer. And finally, once one of these audio, text, or image nodes are executed, each one with their pertaining inference provider, right? If it's an audio node, we are going to need to generate the audio with the level labs. If it's text, we just directly run Llama 3.3. And if it's an image node, we will generate an image using Together's AI Flags endpoint. And finally, we will summarize the conversation so that Ava can handle the context better. And now, before we start looking at the code, let's understand this whole stateful term. So as we said, Ava's brain is just a graph, right? So as with any graph, it's composed by nodes and edges. But here, in the case of LangGraph, we also have a state. And is this state the one that handles all the information that is being shared and populated in all these different nodes? And this is going to make much more sense once we look at the code, I promise. So let's do that. So now, how is everything that we have discussed reflected now in code? Well, let me tell you, I think it's quite straightforward and probably even simple to understand. So let's pay attention to the module graph that we have within the AI Companion directory, which, by the way, if you don't know, this whole course is open source and it's free, of course, and you have the link down below to this GitHub repo. So yeah, go ahead and clone the repo if you want to follow this whole thing in your own IDE. So here in the module graph, now we have different files for the edges, the nodes, the graph, and the state. So let's have a look at those. So let's start by looking at the nodes. And what we have here are different functions that would represent each node. And in each function, you should be looking at two things, actually. First of all, at the parameter that each function has, the state. We are going to be looking at the state just in a couple of seconds. but we have just our own Pydantic class, the AI companion state, right, or Ava's state, and also the return type. So what we have is a dictionary, and this dictionary is the one that is going to be modifying the state. Again, you will understand just in a couple of seconds once we look at the state. And here we have all those nodes that we commented before, right? So the image node will be the one that would create an image, and it would answer depending on just the whole conversation. We also have the audio that would use 11 labs, and we have the summarized conversation, the memory extraction. So we have it all. And you should have a look at the code by yourself and just understand it, dig deep, just get and understand every function. But I think in this video, maybe we can look at the router node, which is just the one that I mentioned before, right? This agentic pattern that what it does is just to determine what to do, right? So it determines the flow of the application. And what we have is actually something very, very simple. So we actually have just a couple of lines of code. And what we do is we build a chain. We build this chain by just using a prompt that I will show you in a second with the structure output, right? So this and that output is going to be this class, the router response, which we have over here. And this indicates the model how to respond. So what we have is the response type, which already the name kind of tells what it is, right? Which kind of response should Ava give? And we give a description just telling what it is to the model. And this works well because we have the router prompt. And this is just a router prompt that you should have a look at it by yourself. But essentially what we do is just to really explain to her all the rules for her to understand when it should be an image generation, when it should be an audio generation, and what are the general rules. So I'm not going to read this whole prompt right now. You have it by yourself. You can really look at it and understand why we have done all these things. And now coming back to the node function, right? So we have created that chain that uses the prompt and that structure output. So now we have to invoke that chain, right? With this asynchronous invoke function that gets us the answer. And it is this answer now that we are going to kind of like plug into the state by using this, right? By returning this workflow, right? Because now the workflow is one parameter of the state. And let's have a look at the state class right now. And what we have is just a Python class that inherits from another class, which is the messages state class, which allows us to really track the conversation history and also keep that last message that we receive. But essentially it's just a Python class. You set up the arguments or the parameters that you want to be storing and that you want to be saving. And those for us are these ones, right? So we have the summary of the conversation, the workflow. So this is just what we have done here, right? We decide the workflow based on the router prompt. So we keep that now in the state. Same thing also for the audio buffer, the image path, the current activity, and the memory. And another node that I want to show you in this video is this context injection node that injects the context of Ava's current activity. And I think this node is quite special because I think this is part of what makes Ava just act so human-like, because she has an activity. So Ava has a schedule, and we can have a look at it, and you can have a look at the code by yourself. But essentially what we have is just kind of like time frame things or that she's gonna do, right? For example, she starts a peaceful morning review in personal machine learning project results, right? So, and also part of Ava's personality is that she is also a machine learning engineer like Miguel and I. And this is really cool because now Miguel and I, we can both talk with Ava about machine learning without boring her. So those would be two of the nodes that we have built, but as I said, code is open source. Just dig deep into it, understand each node by yourself. You're going to really see how everything makes sense due to this graph architecture. Okay, so we have seen nodes and the state. Let's have a look now at the graph and the edges. So we have just a bit more kind of like complex edges. So this would be conversational edges. We will see that later. And we have the graph. And it is here in this file where we put together nodes and edges. And we do that by using the class state graph which uses our state. And then what we do is just to start adding those nodes, and then we connect those nodes via edges, right? So we have the kind of like the start node that then goes to the memory extraction node, and then we have the memory extraction node that goes to the router node. And we continue to do that until we have the final graph build. And the last important element of LangGraph that you should understand is the compilation. So once you have that graph built, you have to compile it. And you can compile it using a checkpointer, which actually has a checkpoint of the state. And this is what we call the short-term memory that we implement via SQLite. And we are going to explain you this better in the next lesson, along with the long-term memory that we implement using Quadrant. And finally, to finish up with this video, and as promised in the intro, let's have a look at LangGraph Studio. So LangGraph Studio is a very powerful app that allows you to take your graph or your agentic system that is a graph, and allows you to run it with the state that you want to put. So you can just change anything from the state. For example, the message, we can put something about what's my favorite movie. And we can execute this by just clicking submit or just clicking command enter. And this is going to execute the graph as it does, really, right? And here, for example, we have seen that for giving us an answer, it went on and used the conversation node, right? So the previous node was the memory injection, and the next one is the summary conversation node. And for example, we can see here the answer from her, which is ex machina, right? Because this is something that I've told her in previous conversations, so she knows that, right? So look at this, for example, this is the memory context. So by using the long-term memory, we have extracted that I have already told her that my favorite movie is Ex Machina. Also, somehow pizza is semantically similar to movies. Also, I don't have that many records in the long-term memory. But yeah, this is all we'll be explaining in the next lesson. So really subscribe if you haven't, because I think it's going to be a really good one. But yeah, it not only allows you to run the graph, it also allows you to debug it or to inspect it, right? We can see, for example, what was the result of the context injection, right? We have, for example, got that the current activity is that an evening routine while catching up on NASA's latest exoplanet discoveries, right? So this is Ava's activities, right? And then we can see how the output of the router was conversation, right? So that was what we saw before. The response type is conversation. And yeah, this is truly, truly powerful. You can even rerun from different parts of the graph. You can even change the state or understand the state, rerun it from that part, and then you see, right? So you can change something about the memory context, use something about the state, and rerun it from that point. So extremely, extremely powerful for you to debug your applications. And how do you set this up, you might ask? So it is quite simple. So they have this article that explains you very, very simple. So you have two ways. So you could use the LangGraph desktop app that for me was causing a lot of errors. So I actually went and used the development server. And the only thing that you have to do is to pip install this package, or in my case via UV. So UV pip install this package, and then just launching it with LangGraph. So if we open cursor, we see here that I just run this. So by just running that, it directly opens up LangGraph Studio. Oh, and something else that you gotta have is just in your project directory, you gotta have two things. So one, you gotta have your graph already compiled, and you gotta have this in a independent variable so that you can then take it using the langgraph.json. So you need this file, and in this file you have to set up the dependencies. So this would be all the dependencies. So this will take the pipe project tom with all the dependencies, and then you have to point at the agent or the agent. So you might have even more than one agent. So here we point at it, right? And you also use your .env file so that it takes all your environment variables, for example, your Grok API key, to be able to run inference using Llama 3.3. And that concluded lesson 2 of Ava, the WhatsApp agent. And I really hope you got a base understanding of how LangGraph works. But if you didn't, please write me a comment in the comment section below with just anything that wasn't clear or just any questions that you might have. And if you got to this part of the video, I would actually appreciate if you can just tell me a little bit about yourself, so about how much experience do you have with Python, with programming, with artificial intelligence, so that I know more or less who is watching these videos, and then I just tailor the next lessons to you. Also, I'm going to put, like always, links to all the relevant information, and something that I think is really amazing is just LangGraph Academy has a free course on LangGraph that is really good. I did it myself and I actually recommend it. And finally, I want you to understand that what you have learned today with LangGraph and this kind of agentic frameworks allows you to build very powerful real world applications. So Ava so far is just kind of like a sophisticated conversational machine, right? She's able, let's say, to pass the Turing test. She really acts humanly, but maybe this doesn't have those real world implications. So you can really think and build those applications, right? So think about, for example, an automated appointment setting, right? So you, via WhatsApp, you can set, confirm, and reschedule just dates that you have in your business or business that you want to sell this service to. Maybe like a personal assistant. So maybe like in the movie Her, you can have a system like Samantha that manages your calendar, the emails, tells you about the weather, and everything could be conversational in WhatsApp. More things, you could even have maybe like a customer support agent that is connected via a database tool to your database, and then it tracks the orders and maybe manages returns. And more. So think about a financial advisor. So there are different API keys, so APIs that connect to maybe like the Yahoo Finance API that connects to the market, and maybe you can get market updates. Also, you could use XAI API key, so you can get real-time information about what is happening in Twitter or in X, and then maybe this can tell you about the market. And think about healthcare as well. So you can have a conversational WhatsApp agent that maybe sends reminders to patients, or maybe like in case of urgency, it acts, right? It does something. And you can build these applications by just writing the specific tools for these kind of use cases and just give that to the agent. And that's it. It's just nodes, edges, and a state. And we have learned that today. Well, that really was all for lesson 2. I'll see you in the next lesson. Bye-bye.